Hi, I'm Nick Murray. I'm a grade 12 student in STEM this year. And so this project sort of had two components to it. The first part was to create a functional solar farm that we would then place on the roof to generate electricity for our classroom. However, this was shut down due to regulations, so we actually ended up working more on our proof of concept solar tracker, which was sort of a smaller scale version of things implemented in industry, and it's basically able to find the brightest light source and follow and direct the solar panel towards that to maximize its efficiency.
To work on this project, we had to understand many concepts, including the photovoltaic and photoelectric effect, light-dependent resistors, and analyzing and solving circuits. We also had to familiarize ourselves with many skills, including working with the microcontroller Arduino, which we've worked with in the past in the STEM program, and coding, as well as creating a feedback loop, and many other skills went into the process of this project.
This project relied very heavily on the coding aspect of it, so as a result we put a lot of research and time into being able to take the information that the LDR provided and kind of relay that through the code along with the Arduino to kind of accurately control the actuators.
Well, we were able to successfully complete a proof of concept solar tracker that used two calibrated light-dependent resistors along with a 180 degrees of rotation servo attached to a feedback sensor actuator system that took the input from the light-dependent resistor and determined what the brightest object was in the sensor's field of view and which direction should orientate the panel to get the highest efficiency of light crossing it.
What made a huge impression on me was the fact that we were able to create on a smaller scale something that would be so important for our planet, and we were able to create it for under $25.
What I took away from this project is the knowledge that there's a lot of public resources that you can find online everywhere, and they're not so readily available, and the good thing about that is like a lot of them you can implement in your daily life to kind of solve issues that you see out in the world, which is kind of a undervalued resource that we all have.
Well, the part of the project that really made an impression on me was the fact that we were using off-the-shelf components to sort of mimic something that's actually being done in places all around the world. I think that it's really important to sort of develop the skills and understanding of technologies that are actually important and out there in the world, and how they can actually have a real application to do something like create clean energy.